The integers are the whole numbers that you see as tick marks on the number line. But in between each of these integers, you have these large spaces that you can't describe with just integers. You have to use other numbers to represent the space in between the integers. And to do that, we have decimals and we have fractions. Now, any number between two integers can be represented both as a fraction and as a decimal. To demonstrate this, I'm just going to enlarge essentially this section of the number line right here. So this section of the number line is now going to be represented right here. We have 0 over here and 1 over here. And we have this massive space in between where there are no integers. So to describe this, as I mentioned, we have decimals and we have fractions. I'll describe fractions first. Fraction is essentially a way to divide up this section inside of here into equally spaced segments. So if we put one right in the middle, we've cut it in half or into two pieces. So 2 pieces, so we have a 2 on the bottom of our fraction. If we just go one of those 2 pieces, we have 1 over 2, or 1/2. And that is what this point here is. If we want to go further, we can divide it up into 4 segments. Now we have 4 equal segments. If we decide we want to go 1, 2, 3 of those segments, we can write this as a fraction with a 4 on the bottom because there's 4 parts, and we've gone 3 of them. So we write this as 3/4. And so you may notice that if you go 2/4, that's the same as going 1/2. So 1/2 and 2/4 are the same thing. And so this is kind of the idea of fractions. You divide up the space between the integers into equal parts, and you put that number on the bottom, or the denominator of the fraction. And then the number of those parts that you're counting is the number on the top of the fraction. And I've divided this up into 2 and then 4 because that's easy to draw. But you can divide up the space between the integers into as many sections as you like. You can divide it up into 3, you can divide it up into 5, 7, 10, any number of parts. And that's the number that'll go on the bottom. This provides a good transition into decimals. A decimal representation is essentially dividing up the space between 0 and 1 into 10 different segments. So I'll go ahead and see if I can draw that up a little bit. But so we've got 5 from here to here, 1, 2, 3, 4, 5, and then 6, 7, 8, 9, and 10. All right, so you've got the space between 0 and 1 divided up into 10 parts. With decimals, though, instead of saying, for instance, instead of writing this as 3/10, which is a valid way to write this particular point as a fraction, you would write this as 0.3. Because we use the decimal system, every number place to the right of the decimal means you've divided up this space between the two integers into 10 equal parts, and this is how many of the parts we're talking about. So we take the integer immediately beforehand and then count forward 3 of the 10 parts, and that gives us 0.3, which is the same as 3/10. And so you can take the space between any of these integers. For instance, if you wanted to take the space between 3 and 4 and count 6/10 of the way from 3 to 4, you would write this as 3.6, because you've gone 6/10 of the way from 3 to 4. And so you can describe any number on the number line using decimals or fractions. If you want to get even more specific than tenths, you can divide up For instance, if you wanted to go somewhere in between 0.3 and 0.4, you could divide this space up here into 10 equal parts, and then however many of those parts you went forward from 0.3, you would write that as another decimal here, so 0.3 and however many parts. So that is a quick overview of integers, decimals, and fractions. In this video, I want to discuss improper fractions and mixed numbers. Just to review real briefly, a fraction has a numerator and a denominator. And the denominator represents how many parts we're breaking up the whole into, and the numerator, the top number, represents how many of those parts we're counting. So if we say 3/4, it means we've broken up this whole, whatever it may be, into 4 equal parts, and then we're considering 3 of them. So for instance, I've shaded 3/4 of this rectangle here. So that's fractions. When a numerator is smaller than a denominator or less than a denominator, we have what's called a proper fraction, because the value of the fraction is between 0 and 1. So 3/4 is a good example of a proper fraction. If the numerator is larger than the denominator, for instance, if we have 5/4, this is what's called an improper fraction, because its value is greater than 1. So for instance, if we were to try to draw this, and we had this same rectangle, divided it up into 4 parts, we could shade 1, 2, 3, 4, and then we run out, and we have to draw a whole nother rectangle to shade that 5th part. And so this is considered an improper fraction. It just represents a number that's greater than 1. And so it's not really an ideal way to write this quantity. Oftentimes what you'll see when you have a quantity like this, where it's greater than 1, you'll see what's called a mixed number. This is a whole, so we can call that 1, and this over here is another 1/4. So the way you'll see this written commonly is 1 and 1/4. It's called a mixed number because you have an integer part mixed with a fractional part. And so essentially what you're saying is 1 plus 1/4 or 1 and 1/4 when you have this sort of number. Now you can convert between improper fractions and mixed numbers pretty easily, and so I'll demonstrate now how to do this. Let's take, for instance, 2 and 4/5. So this is a mixed number, and we want to convert it now to an improper fraction. So to do that, we take the denominator, 5, we multiply that by the whole, by the integer here, or the whole number, 2. So we have 5 times 2, which is 10, and then we take that product and add to it the numerator. So 10 plus 4 is 14. And so then we write 14 as our new numerator, and we keep 5 as the denominator. And so 2 and 4/5 is the same as 14/5. If we want to go in reverse, we just have to do this process backwards a little bit. So let's say we have 12/9. What we got to do is divide 12 by 9. 9 only goes into 12 one time, so we take out 1 as the whole number, subtract 9 from 12, and we're left with 3. So 12/9, or 12 minus 9, is equal to 3. So we've taken out the whole, and we've got the 1 here, and so what we're left with is 3 of our original 12. And so we can write that as the remaining fraction here. We have 1 and 3/9. And so that is how you convert an improper fraction to a mixed number. Since this is an overview of all the foundational concepts, I want to devote a little bit of time to the 4 basic operations. In this video, I'm going to discuss how to perform addition and subtraction with large integers, decimals, and fractions. So first, large integers. Let's take, for instance, 248 and 135. So first, to add these together, what you want to do is you want to line things up at the decimal point. In this case, the numbers don't have anything past the decimal point, so you just line them up at the ends. You then start from the right and you add vertically. So we have 5 plus 8, that's equal to 13. And so we can't fit 13 in this single decimal place here, so we'll write a 3 and carry the 1. And so now when we go to add this column, we have 3 numbers in the column. And so we have to add 1, 4, and 3. And so together those are 8. And then we add 2 and 1 in the final column to get 3. So that's addition. Let's try out these same 2 numbers with subtraction. So we'll have 248, but this time minus 135. We'll subtract 5 from 8. 8 minus 5 is 3. Then we move to the next column. 4 minus 3 is 1, and 2 minus 1 is 1. And so that's subtraction with integers. Next, we'll go ahead and move on to decimals. Decimals are going to work largely the same way as integers, but with decimals, you have to be careful to line up the decimal point so that you're adding and subtracting in the right columns. So let's take 0.435 and we'll add 0.019. And so I've already done it here, but if you don't already have it lined up, what you want to do is line up the decimals, as I was mentioning back here. Line up the decimals vertically, so that way you know you have the right place values lined up. So we'll have 5 plus 9, which is 14. Again, we can't put 14 down here, so we have to carry the 1. Now we have 1 plus 3 plus 1. That's equal to 5. And then over here we just have 4 and 0, so we'll write a 4. And so now that we've added these, we need to make sure the decimal point drops in the right spot, and we'll add a leading 0. And so this is addition of decimals. We'll once again take the same 2 decimals and do subtraction. So 0.435 minus 0.019. Now we have 9 minus 5. Unfortunately, that's a negative number, so we have to borrow a 1 from over here. So this 3 is going to become a 2, and this 5 is going to become a 15. And so now we have 15 minus 9. And that gives us 6. 1 minus the 2, because we borrowed the 1 for the 15. 1 minus 2, or 2 minus 1, is 1. And then 4 minus 0 is just going to be 4. And once again, we'll drop the decimal and add the leading 0. And so this is integers and decimals, and those are both pretty straightforward. But then we have fractions. Fractions are easy enough if the denominator is the same. If the denominator is not the same, you have to convert one or both of the fractions to a different denominator before you can add or subtract them. So let's take, for instance, 1/3 and 1/6. We'll use these as our example this time. So 1/3 plus 1/6. We can't just add them together because the denominators are different. What we have to do is get a common denominator between the 2 fractions. To do that, you find the least common multiple of both of the denominators. In this case, the least common multiple is 6, because 6 and 3 both go into 6 evenly. 3 goes into 6 2 times, so we'll need to multiply 1/3 by 2 over 2. and that gives us 2 over 6. And so now what we have is 2 over 6 plus 1 over 6. Now that the denominators are the same, all we have to do is add the numerators together, and then we retain the same denominator as both of the fractions. So we have a 6 in the denominator, and 2 plus 1 is equal to 3. And so we have 3 over 6. So that's addition. We've already done the hard part of converting the two fractions, or of achieving a common denominator between the two fractions. So for subtraction, all we have to do is write the converted form. We have 2/6 minus 1/6, and just like we did above, we'll retain the 6 in the denominator, and then we'll just use subtraction on the numerators. So 2 minus 1 is 1. And so that is addition and subtraction for integers, decimals, and fractions. In this video, we're going to look at the last two of the basic operations, multiplication and division. So to start with, let's take the case of integers. Let's take 7441, and let's multiply it by 7. All right, so we want to line up the two numbers at where the decimal point would be, right there. And then starting with the digit farthest to the right in the bottom number, in this case there's only one, but starting with that digit, we'll multiply by all the digits in the top number, starting with the one on the right. So we have 7 times 1, which is 7. 7 times 4, which is 28. So we'll put an 8 here and write a 2 up here. 7 times 4 is once again 28. But we have to add this 2, so we have 30. So this becomes a 0, and we add a 3 up here. Then we have 7 times 7, which is 49. Adding 3 more, we get 52. And so we can put the 5 in there. So that's multiplication for integers. If we had more digits in the bottom number, once we had finished multiplying the top number by this digit, we would then move on to this digit and multiply all of those numbers, but start in this, this digit place, and then add up all the results at the end. But we just had one, so that's the answer. Division is a little bit more complicated. The way to do division, I'm going to be showing a method called long division. You write the number that you're dividing, and then to the left of that, you write the number you're dividing it by. And so in multiplication, we worked from right to left, but in division, we work from left to right. So we're going to take the digits individually if we can, and see how many times this number is going to fit into them. So first we have 7 going into 7. 7 can go into 7 one time, and 1 times 7 is equal to 7. So when we subtract this number from that number, we just get a 0. And so then we move on to the next digit, and I'll write a 4 here. 7 cannot go into 4 any times, so we'll write a 0 here, and we'll add the next digit. So 44 now. 7 can go into 44 6 times, so we'll write a 6 here. 6 times 7 is 42, and when we subtract that out, that leaves us with a remainder of 2. And so now we drag in the last digit, which is a 1. So we have 21, and 7 goes into 21 3 times. So 3 times 7 is exactly 21, and so we have a remainder of 0. So this is the full solution to this division problem. If 7 had not evenly gone into the last number here, we would have had to put a decimal point here and keep on going until it either terminated or we found a repeating pattern of digits, at which point we could stop. So this is multiplication and division for integers. I also want to demonstrate multiplication and division for fractions. It's much simpler particularly than the long division here. It's really just two different forms of multiplication. So let me demonstrate that. Let's say we have 1 over 3 times 3 over 4. Now, all we have to do to multiply fractions, we don't have to worry about common denominator or any of that like we do with addition and subtraction. We just multiply the two numerators. 1 times 3 gives us 3. And then we multiply the two denominators. 3 times 4 gives us 12. And so it's a lot easier in one sense to multiply two fractions than it is to add or subtract. And so that's really all there is to fraction multiplication. Fraction division just requires one extra step. And so what it's going to look like is if you have 1/3 divided by 3/4, that you take the reciprocal of the second number and then change the division sign to a multiplication sign. So this becomes 1 over 3 times, this was 3 over 4, so we'll take times 4 over 3. And so we flipped the fraction and changed it to a multiplication. And then all we have to do is just multiply numerator and denominator like before. 1 times 4 is 4, and 3 times 3 is 9. And so that is a brief review of multiplication and division for integers and fractions. In this video, I'm going to talk about exponents and roots. An exponent is a number that tells you how many times to multiply the base number by itself. So for instance, if we have 2 raised to the second power, like this, what this is telling us is that we need to multiply 2 times 2. Now, if we had 2 raised to the third power, this would be the same as 2 times 2 times 2. So the exponent is saying how many times to multiply this number by itself. A root is kind of the opposite of this. So let's take, for instance, 16. This is a radical symbol, and this tells us that we're taking a root. If there's no number up here, the number is assumed to be 2. So without any numbers up here, the radical sign designates a square root, or a root to the power of 2. So the square root of 16 is the number that has to be multiplied by itself twice in order to equal 16. So the square root of 16, by definition, if it is squared or raised to the second power, it equals 16. And so the square root of 16 is 4, because 4 raised to the second power, or 4 times 4, is equal to 16. And so roots and exponents are kind of inverse operations. But you can actually express roots as exponents. So for instance, if we wanted to go back to the square root of 16 here, we can write the square root of 16 as 16 to the 1/2. And so essentially, if you have 1 over a number in the as an exponent, you're essentially taking that number's root of the number in question. So like I was saying, the 2 up here that's omitted for a square root, that's the same as 1/2, a power of 1/2. You can also have other fractions or other powers of roots. So for instance, you might take 8 to the 1/3, or the third root of 8. So this would be a number that you have to multiply by itself 3 times in order to achieve this. So the third power of 8 raised to the third power is equal to 8. And so this number would be the same as 2, because 2 times 2 times 2, or 2 to the third power, is equal to 8. And a couple other things about exponents. Any number raised to the 1 is just the number itself. So 2 raised to the 1 is just 2. And any real number raised to the 0 is equal to 1. It doesn't matter if it's a positive number or a negative number. Any real non-zero number raised to the power of 0 is equal to 1. You may notice that all of the exponents and roots we've looked at so far here are whole numbers or fractions of whole numbers. You can, in fact, have roots that are, for instance, say this is 2 raised to the 2.3. You can have this sort of quantity, but it's not going to be easy to calculate by hand, and really you're going to want to use a calculator if you encounter anything that has a decimal in the exponent. So that's a good overview of exponents and roots.
Adding and subtracting fractions. To add and subtract fractions, first make sure that the denominators are the same. If they aren't, like in 5/9 minus 1/6, then we need to find the least common denominator. The least common multiple of 9 and 6 can be found by listing the multiples 9, 18, 27, etc. 6, 12, 18. Our least common multiple is 18, so we're going to change both of our fractions, 5/9 to something over 18, and 1/6 to something over 18. 9 times 2 is 18. So since we multiplied our denominator times 2, we must also multiply our numerator times 2. 5 times 2 is 10. 6 times 3 is 18. So we must also multiply our numerator times 3, and we get 3/18. So that means that 5/9 minus 1/6 is equal to 10/18 minus 3/18. Now we just subtract our numerators and put that difference over our denominator of 18. 10 minus 3 is 7. Then, if you can simplify the result, you should. But in this case, 7/18 cannot be simplified, so that's our answer. Let's look at an addition problem. Again, we've got to see if our denominators are the same, and if they aren't, then we need to change them so that they are. So we're going to find the least common denominator for 3 and 5, which means we're finding the least common multiple for 3 and 5. So I'll list the multiples: 3, 6, 9, 12, 15. And my multiples for 5, 10, 15. So my least common multiple is 15, which means I'm going to change both my denominators to something over 15. 2/3 equals something over 15. And 4/5 equals something over 15. So to get from 3 to 15, we have to multiply times 5. So we need to do the same to our numerator. 2 times 5 is 10. 5 to 15, we have to multiply 5 times 3. So we do the same to our numerator. 4 times 3 is 12, which means that 2/3 plus 4/5 is the same as 10/15 plus 12/15. And again, we add the numerators and put that result over our denominator. 10 plus 12 is 22. And this is an improper fraction since our numerator is larger than our denominator, so we'd want to change it to a mixed number. To change this improper fraction to a mixed number, we're going to divide our numerator by our denominator. 22 divided by 15 is 1, since 15 goes into 22 one time, with 7 left over out of, and the denominator stays the same. So 1 and 7/15 is our result. Associative property. The associative property states that when adding or multiplying a series of numbers, it does not matter how the terms are ordered. Remember that simplifying within the parentheses is the first step using the order of operations. So you can remember the associative property, the rule for the associative property, because the numbers are grouped or associated with one another. Let's look at a couple of examples. A plus B plus C is equal to A plus B plus C. So again, we're going to do what's in the parentheses first. Let's try this with 2 plus 3 plus 4 equals 2 plus 3 plus 4. So again, we're going to follow our order of operations, or PEMDAS. We're going to start by adding 2 plus 3, 5 plus 4 is equal to 2 plus, and again, following order of operations, 3 plus 4, which is 7. 5 plus 4 is 9, and that does equal 2 plus 7, which is also 9. So you can see it doesn't matter which terms we add first. Since we're doing addition, it doesn't matter what we do first. Let's see what happens when we do the multiplication side. So again, I'm going to use 2 times 3 times 4 is equal to 2 times 3 times 4. According to PEMDAS, we have to start inside our parentheses. So that's 2 times 3 times 4 is 12 is equal to, again, starting in our parentheses, 2 times 3 is 6 times 4. 2 times 12 is 24, and that does equal 6 times 4, which is also 24. Like the commutative property, the associative property is only true for addition and multiplication. Let's look what happens when we try to use it on subtraction and division. So if we tried to use the associative property, it would look like A minus B minus C, but again, it's not going to be equal to A minus B minus C. So I'm going to use numbers like 8 minus 4 minus 2 does not equal 8 minus 4 minus 2. Again, using order of operations, 8 minus 4 is 4, minus 2 does not equal 8 minus 4 minus 2 is 2. 4 minus 2 is 2, and that does not equal 8 minus 2, which is 6. As you can see, the associative property does not work on subtraction. Let's use it on division now. So with division, it would look like A divided by B divided by C, again, will not equal A divided by B divided by C. I'm going to use the same numbers we used for subtraction. So 8 divided by 4 divided by 2 does not equal 8 divided by 4 divided by 2. Let's simplify. Order of operations, 8 divided by 4 must be done first. 2 divided by 2 does not equal, again, parentheses first, 8 divided by 4 divided by 2 is 2. 2 divided by 2 is 1, and that does not equal 8 divided by 2, which is 4. And that's the associative property. Changing a mixed number to an improper fraction. To change a mixed number to an improper fraction, first multiply the denominator times the whole number and then add the numerator. You'll then place that value over the denominator. Let's look at 2 examples. For 2 3/4, we'll first multiply 4 times 2, our denominator times our whole number, and then add our numerator. That value goes over our denominator, 4. 4 times 2 is 8. 8 plus 3 is 11. So 2 3/4 is 11/4 as an improper fraction. Let's look at one more. 4 2/5. Again, we're going to start by multiplying our denominator times our whole number. 5 times 4. And then adding our numerator, plus 2. And that value goes on top of our denominator, 5. 5 times 4 is 20, plus 2, 22/5.
The processes for converting decimal numbers to fractions and percentages are both fairly simple, so I'll demonstrate both on each of these examples here. First, we have 0.35. To convert 0.35 to a fraction, we'll write the 2 digits in here as the numerator, and we'll take a look at the rightmost digit. The rightmost digit is 2 decimal places to the right of the decimal, so we're going to write 2 zeros in the denominator. So we have 35 over 100. And this can be reduced by dividing both the top and the bottom by 5. 35 over 5 is 7. 100 over 5 is 20. So this is equal to 7 over 20. To convert a decimal to a percentage, all we have to do is move the decimal point 2 places to the right. So 0.35 is equal to 35%. In the second example, we have 0.215. Once again, we'll write 215 as our numerator. The rightmost digit is 3 places to the right of the decimal, so we will write 3 zeros in our denominator. 215 over 1,000. We can divide top and bottom by 5, so 215 over 5 is equal to 43, and 1,000 over 5 is equal to 200. So this fraction is the same as 43 over 200. To convert to a percentage, we can just move the decimal point 2 places to the right. So 0.215 is equal to 21.5%. In this final example, we have 0.842. We will once again write these digits as our numerator. The rightmost digit is 3 places to the right of the decimal, so we will once again have 3 zeros in our denominator. 842 over 1,000. We can reduce by dividing top and bottom by 2. 842 over 2 is 421, and 1,000 over 2 is 500. So this fraction reduces to 421 over 500. To convert to a percentage, once again, we'll just move the decimal point 2 places to the right. So 0.842 is equal to 84.2%. The first step in converting a decimal to an improper fraction is to convert the decimal to a mixed number. So we'll convert to mixed numbers first. In this first example, we have 7.6. To convert this to a mixed number, we'll take the whole part, or the part to the left of the decimal, which is a 7, and then we'll take the part to the right of the decimal, which is a 6. Now, we can put the 6 over a power of 10, and there's only one digit to the right of the decimal, so there's only one 0. So we have 7 and 6 over 10. Now we can reduce this fraction by dividing top and bottom by 2. So we have 3 on top and a 5 on the bottom. So this is equivalent to 7 and 3/5. Now to convert this to an improper fraction, we'll multiply the denominator by the whole number and then add the numerator. 5 times 7 is 35, plus 3 is 38. So we have 38 over 5. In this next example, we're going to once again take the whole number part, which is the 5, and then we will put the part to the right of the decimal over a power of 10. 2 places to the right of the decimal, so 2 zeros, 35 over 100. We can reduce this by dividing top and bottom by 5. 35 over 5 is 7. 100 over 5 is 20. So this is equivalent to 5 and 7 over 20. To convert to an improper fraction now, we'll multiply 20 times 5, which is 100, plus 7, which is 107. So we have 107 over 20. In the final example, we'll once again take the whole number part, 3, and then take the part to the right of the decimal, 375 over 3 decimal places, so 3 zeros, 375 over 1,000. Now, we can divide top and bottom here by 125, which leaves us with 3 over 8. So this number is equivalent to 3 and 3/8. Now to convert to an improper fraction, we'll once again multiply 8 times 3, which is 24, plus 3, which is 27. So we have 27 over 8.
Converting improper fractions to mixed numbers. To convert an improper fraction to a mixed number, first we're going to divide our numerator by our denominator. 22 divided by 5 is 4, with a remainder of 2. 4 is our whole number, while 2 is the numerator of our fraction, and the denominator stays the same. So 22/5 as a mixed number is 4 and 2/5. Let's look at one more. Again, to change an improper fraction to a mixed number, we're going to start by dividing our numerator by our denominator. 18 divided by 4 is 4. 4 times 4 is 16, so we have a remainder of 2. 4 goes into 18 4 times with a remainder of 2 out of 4, since our denominator stays the same. This mixed number is special because we can simplify this fraction 2/4, and when you can simplify, you always want to do that. So 4 and 2/4 simplified would be 4 and 1/2. Since the GCF of 2 and 4 is 2, we divide both numerator and denominator by 2. 2 by 2 is 1, and 4 divided by 2 is 2. So 18/4 as a mixed number is 4 and 1/2. Distributive property. The distributive property involves multiplying over grouped addition or subtraction terms. It states that you multiply the number outside of the parentheses by each term inside of the parentheses, and then add or subtract as in the original. You can think of distributing as handing out or giving something out. You're giving out the number on the outside of the parentheses to the numbers on the inside of the parentheses. We're going to look at two examples, one with addition and one with subtraction. If we were doing 2 times the quantity 5 plus 3, then we could use the distributive property to simplify this by distributing the 2 to the 5, 2 times 5, plus 2 times 3. Then we would simplify. According to PEMDAS, we need to multiply first. So 2 times 5 is 10, plus 2 times 3 is 6. Finally, we combine 10 plus 6 for 16. Let's look at this subtraction problem. If we wanted to simplify 4 times the quantity 5 minus 2, we would start by multiplying 4 times 5 minus 4 times 2. And then we would simplify. Following the order of operations, we're going to multiply first. 4 times 5 is 20 minus 4 times 2 is 8. And 20 minus 8 is 12. Dividing decimals. To divide decimals, first move the decimal point in the divisor so that it's a whole number. Then move the decimal point in the dividend the same number of places. And finally, move the decimal point up so that you know where it goes in your answer. So this means that now we're dividing 25 into 789 and 5/10. Now we just divide as we would with whole numbers until we get no remainder, or you know it's a repeating decimal. So 25 goes into 78 3 times. 25 times 3 is 75. We subtract and we get 3. Bring down the 9. And 25 goes into 39 1 time. 25 times 1 is 25. We subtract. 9 minus 5 is 4. 3 minus 2 is 1. Then we bring down our 5. 25 goes into 145 5 times. 25 times 5 is 125. Then we subtract. 5 minus 5 is 0. 4 minus 2 is 2. And then we have to add on a 0 so that we can continue. Since our remainder isn't 0, we still have 20 here. We need to add on a 0 to bring down, because we can add as many zeros after our decimal place as we like without changing the number. 25 goes into 200 8 times. 25 times 8 is 200, so that when we subtract, we get a remainder of 0. Now that we've reached a remainder of 0, we're finished dividing, and our result is 31 58/100.
Math, 3rd grade. When dealing with fractions of a whole, realize that there's a numerator and a denominator in every fraction. So the numerator is on top and the denominator is on the bottom. So we have a fraction bar right here. And so first, we need to determine what goes in the denominator. So that's the total of amount of spaces we have on the fraction strip. So we have the fraction strip right here, so we need to count the total amount of spaces. So count with me. 1, 2, 3, 4, 5, 6, 7, 8. So we need to put an 8 in the denominator here. Now when it comes to the numerator, we need to count the shaded spaces. And so notice these spaces right here, they're all shaded. So now we need to count those. 1, 2, 3, 4, 5. So there's 5 shaded spaces. And so the 5 is going to go in the numerator because we have the whole amount right here and then we have part of the whole. So right here we have a pizza. And so let's count the spaces of this pizza. 1, 2, 3, 4, 5, 6, 7, 8. So again, if we're doing a numerator and denominator, we put 8 in the denominator. So now we need to count the shaded regions for the numerator. So there's 1, 2, 3, 4, 5 shaded regions. So here for this pizza, there were 8 total pizzas, so 8 is the whole, and then 5 is how many are still there. So there's 5 pieces of pizza still there, so 5 goes in the numerator. So although you may mostly be dealing with a fraction strip, try to take that idea right there and think about just a pizza, and think about, okay, maybe there's 8 or 5 total pieces of pizza, and how many have not been eaten yet. And so that's what you're doing when you look at a fraction strip. So remember that the whole goes in the denominator, and then the shaded regions go in the numerator.
Greatest common factor. The greatest common factor, or GCF, of 2 numbers is the largest value that divides into each of the numbers. Let's take, for instance, 18 and 30. You can find the GCF of 2 numbers by finding the prime factorization of your numbers and then finding what they have in common. So the prime factorization of 18 is even, so it's divisible by 2. So 2 times 9 would be 18. 9 is not prime though, so we need to break 9 down. And the factors of 9 are 3 times 3. So the prime factorization of 18 would be 2 times 3 times 3. 3 times 3 is 9, times 2 is 18. I always like to check after I've factored to make sure I've got it. The prime factorization of 30. 30 is divisible by 2 also, since it's even. So 2 times 15 would be 30, but 15 is not prime. So we have to break it down into its prime factors. And 15's prime factors are 3 times 5. So the prime factorization of 30 is 2 times 3 times 5. 2 times 3 is 6, and 6 times 5 is 30. Now again, to find the GCF, we're going to look for what they have in common. 18 and 30 have 2 and 3 in common as prime factors. So we take those factors they have in common and multiply them. 2 times 3 is 6, so the GCF of 18 and 30 is 6. 6 is the largest factor that these numbers have in common. Least common multiple. The least common multiple, or LCM, of 2 numbers is the smallest value divisible by both the numbers, or it's the smallest number that both of your numbers divide into evenly. The LCM can be found by finding the GCF, or greatest common factors, and the remaining factors. The LCM is the product of the GCF and those remaining factors. For example, if we wanted to find the LCM of 18 and 30, we would first need to factor them. 18 is 2 times 9. Since 9 is not prime, we would factor 9 to 3 times 3. 30 is also even, so we'll start with 2. 30 is 2 times 15. 15 is not prime, so we factor 15. 15 is 3 times 5. The GCF, or greatest common factor, is 2 times 3, or 6. So our least common multiple is the product of our GCF, 6, and the remaining factors. The remaining factors are 3 and 5. So 6 times 3 times 5. 6 times 5 is 30. 30 times 3 is 90. So the smallest number that 18 and 30 will both divide into evenly is 90. Multiplying decimals. When multiplying decimals, instead of lining up the decimal point, we line up the last digits on the right. So if we were multiplying 4 and 23/100ths times 9 and 75,000ths, we'd want to line up our last digits. So 3 is the last digit in 4 and 23/100ths, and 5 is the last digit and 9 and 75,000ths. There's my 7, my 0, my decimal, and 9. Now we multiply just like we multiply whole numbers. So starting with 5, 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus 1 is 11, carry the 1. 5 times 4 is 20, plus 1 is 21. And then I'll get rid of these. For our next number, now that we're multiplying times the 7, we need a 0 placeholder. 7 times 3 is 21. Write your 1, carry your 2. 7 times 2 is 14, plus 2 is 16. Write your 6, carry your 1. 7 times 4 is 28, plus 1 is 29. Get rid of those. Then we need 2 zeros for placeholders. And when we multiply times 0, 0 times 3 is 0, 0 times 2 is 0, and 0 times 4 is 0. We just get a line of zeros. So moving on to our last digit, now we need 3 0 placeholders before we multiply times 9. 9 times 3 is 27. Write the 7, carry the 2. 9 times 2 is 18, plus 2 is 20. Write the 0, carry the 2. 9 times 4 is 36, plus 2 is 38. Then just like we would with any other whole numbers, we're going to add our results together. 5 plus all these zeros gives us 5. 1 plus 1 is 2. 1 plus 6 is 7. 2 plus 9 is 11. Plus 7 is 18. Write our 8. Carry our 1. 1 plus 2 is 3. And then we have 8 and our 3. To determine where the decimal point goes when you've multiplied your decimals together, we're going to take how many numbers there were behind our decimal in our first number and how many numbers there were behind our decimal in our second number and add those together. So since we had 2 numbers behind the decimal here and 3 numbers behind the decimal here, then our result will have 5 numbers behind the decimal. 2 plus 3 is 5. 1, 2, 3, 4, 5. So this is the result of multiplying my 2 decimals together. Ordering fractions. When ordering fractions, you must first look at the denominator. If the denominators of the fractions are the same, then you order them according to the numerators, with the values increasing left to right. Let's look at an example. you can see all the denominators are the same. So we're going to order these fractions by looking at our numerators. If we're ordering them from left to right, or from least to greatest, then the smallest number would be our biggest negative number, -7/9. Our next number would be our next negative number, -4/9. Next biggest would be our first positive number, 2/9. And finally, 4/9. Now let's look at some fractions that don't have the same denominator. For these fractions, we could first find the least common denominator, so that we could have all the same denominator and then order them by the numerator. The least common denominator, or LCD, for 4, 12, 2, and 6 would be 12. So first, we're going to convert all these fractions to have the denominator of 12. 3/4. To convert 3/4 to something over 12, we'd need to multiply 4 times 3. So we'll do the same to our numerator. 3 times 3 is 9, and 4 times 3 is 12. So 3/4 is 9/12. -7/12 already has our least common denominator of 12, so we're going to leave it alone. 1/2, 2 would need to be multiplied by 6 to get 12, so we'll do the same to our numerator. 1 times 6 is 6, 2 times 6 is 12. -5/6. 6 would need to be multiplied by 2 to get 12, so we'll do the same to our numerator. 5 times 2 is 10, 6 times 2 is 12, and of course, it's still negative. Now we can order our fractions based on their numerators, from least to greatest, from left to right. Our smallest number is our biggest negative, which is -10/12. Then our next negative, -7/12. Then 6/12. And finally, 9/12 would be our largest number. Order of operations. Before simplifying expressions, it is important to know which operations to perform first if more than one operation is present in the expression. Please excuse my dear Aunt Sally, or PEMDAS, is often used for remembering the order of operations. P is for parentheses. Anything in parentheses should be done first. This one's a little misleading though, because it's not just parentheses that should be done first, it's all grouping symbols. Brackets, absolute value, anything that groups numbers together. Followed by exponents, and then their inverses, roots, should be done next. Following that is multiplication and division. And this is special because multiplication and division, it's not that one needs to be done before the other. These are just worked from left to right. So in your expression, when you're looking from left to right, you'll do all your multiplication before you do your division. Finally, addition and subtraction work the same way as multiplication and division. So these will also be done from left to right, but these will be the last things done when simplifying an expression. Let's put PEMDAS to work. We're going to simplify this expression. So according to PEMDAS, we need to start with our parentheses, or our grouping symbols. 3 plus 9 then is where we need to start. That's the only thing we're going to simplify, so everything else stays the same. 2 plus 5 minus 3 plus 9 is 12. Divided by 2 squared. We're done with our parentheses or grouping symbols, so next up is exponents. And we have an exponent right here at the end, so 2 squared will be the next thing we simplify. 2 plus 5 minus 12 divided by 2 squared means 2 times itself 2 times, which is 4. Then we have our multiplication and division from left to right. So as I look from left to right, all I have is this one division operation to perform. So that'll be the next thing we do. 2 plus 5 minus 12 divided by 4 is 3. Finally, we get to our addition and subtraction. Again, these are worked from left to right. So 2 plus 5 is 7. Bring down our minus 3. And 7 minus 3 is 4. So this expression, simplified, would give you 4. Now let's see what happens if we ignore the order of operations and just work from left to right. If we were just working from left to right, we would start with 2 plus 5, which would give us 7, minus 3 plus 9 divided by 2 squared. Then we would do our 3 plus 9, so we'd have 7 minus 12 divided by 2 squared. 7 minus 12 would give us negative 5, since we can add the inverse. 7 plus negative 12, negative 5, divided by 2 squared. Negative 5 divided by 4 is negative 5/4. So as you can see, if we ignore the order of operations, we get a completely different answer, which is why it's very important to make sure you're always going in the correct order whenever you solve or simplify an expression. Prime number. A prime number is a natural number higher than 1 that cannot be divided by any other natural number besides 1 and itself. Here is a list of the first 7 prime numbers. 2 can only be divided by itself and 1. 3 can only be divided evenly by itself and 1. 5, the same. 7, so on and so forth. Notice that in our list of prime numbers, the number 1 is missing. 1 is not considered a prime number since it doesn't have 2 divisors or 2 factors. 1 can only be divided by itself, 1. So to be a prime number, you have to be able to divide it by 2 numbers, 2 and only 2. Like on 2, we can divide it by 2 and by 1, but nothing else will divide 2 evenly. Notice also we're missing the number 4. 4 is not a prime number because it can be divided by 1, 2, and 4. So it can't only be divided by itself and 1. That's the same with 6, 8, 9, 10, etc. Those kinds of numbers are called composite numbers. So prime numbers are numbers that can only be divided by 1 and itself, and composite numbers would be all the other numbers. However, 1 is neither. 1 is neither prime nor composite. It's special. Rates and unit rates. Ratios are considered rates when they compare 2 different units, like miles per hour or cost per ounce. A unit rate is one in which the numerator of the fraction is compared to a denominator of 1 unit. That way you can tell, for instance, like how much just 1 ounce of something costs. And you'll see unit rates a lot at the grocery store. Under or next to the price of an item, it'll tell you how much that item costs for every 1 ounce or for every 1 thing in the package. So let's look at a problem dealing with rates and unit rates. Dave is driving 240 miles to his aunt and uncle's house. If he gets there in 4 hours, how many, and here's the key right here in the question, how many miles per hour did he drive on average? In that question, they're telling you how to set up the problem. They're telling you to put miles over hours. So we're going to start with that. Miles per hour. And now we can substitute the information in from the problem. So they told us how many miles. He's going 240 miles. And they told us how many hours. 4 hours. So we can put that into our rate, 240 miles for his 4 hours. So right now this would be considered a rate since we have two different units, our miles and our hours. But to determine our unit rate, or to figure out his average, we would need to divide or simplify our rate to find our unit rate. So if we want to have a denominator of 1, then we're going to have to divide 4 by 4 to get our 1. And if we divide our denominator by 4, then we must also divide our numerator by 4. 240 divided by 4 is 60. So again, this is miles per hour. So what this unit rate tells us is that on average, he was going 60 miles for every 1 hour. So your answer could be written as 60 miles per hour is how fast Dave was going on average. Multiples. You can think of multiples as like counting by that number. So for instance, the multiples of 2 would be 2, 4, 6, 8, 10, etc. The multiples of 3 would be 3, 6, 9, 12, 15, 18, etc. The multiples of 4 would be 4, 8, 12, 16, 20, and so on. Sometimes you're asked to find the LCM of 2 or more numbers. The LCM is the least common multiple. Least meaning the smallest, common meaning the same, and multiple. So if we wanted to find the LCM of, let's say, 2 and 3, the least common multiple of 2 and 3, so the smallest number that 2 and 3 have in common, would be 6. So that's the LCM of 2 and 3. The LCM of, say, 3 and 4, the very smallest number that they have in common would be 12. And you can find the least common multiple of bigger numbers, like, say, the least common multiple of 12 and 15. So 12 would be 12, 24, 36, 48, 60, 72, etc. While 15 would be 15, 30, 45, 60. So if we were finding the LCM of 12 and 15, the smallest number they have in common is 60. So the least common multiple is 60. Scientific notation. Scientific notation is used to write larger numbers in a shorter form. And the form is a times 10 to the n, where a is a number that is greater than or equal to 1, but it's less than 10. And n is the number of times we must move the decimal, and in which direction. Let's take this number, 230,400,000 400,000. It's a pretty big number. We can write this in scientific notation by taking our decimal, which is at the end of our number, and moving it 1, 2, 3, 4, 5, 6, 7, 8 places to the left, so that our number is now 2 and 304 thousandths. And you see my A is a number between 1 and 10. 2 and 304 thousandths is greater than or equal to 1, but less than 10, times 10 to the 8th. And this number is the same as my original number. We can also use scientific notation to take very large decimal numbers and write them in a shorter form. We do the same thing. Our A has to be greater than or equal to 1 and less than 10, which means we need to move our decimal 1, 2, 3, 4, 5 places to the right, so that it becomes 2 and 304 thousandths times 10 to the negative 5. And that negative exponent lets you know that that's a very, very small number. It's a decimal. It's less than 1. Whereas a positive exponent tells you that it's a very large number. We can use these exponents to compare our numbers very quickly and easily. Looking at these two numbers in scientific notation, I can tell that 1 and 51 hundredths times 10 to the 5th is the larger number because it has the larger exponent. So it's a great method for very large and very small numbers.